Now we finished of alcohols. The number of reactions are there, important reactions of alcohols over, and aromatic alcohols. Aromatic alcohols are said to be phenols. Phenol, hydroxybenzene, the common name phenol, OL, phenol. So what are phenols means? Aromatic alcohols are said to be phenols. Hydroxyl attached to benzene ring are said to be phenols. Now how to prepare phenols? Phenols can be prepared from chlorobenzene. So how to prepare the phenol from chlorobenzene? Phenol is prepared by the action of sodium hydroxide, concentrated, highly concentrated sodium hydroxide at high temperature, 673, nearly 400 degrees centigrade. High pressure, at normal temperature and pressure, the reaction does not take place. So high temperature, high pressure reacts with the sodium hydroxide or potassium hydroxide and gives phenol. So phenol can be prepared by the action of constant sodium hydroxide at high temperature and pressure on chlorobenzene or bromobenzene or iodobenzene. The second method of preparation of phenol from diazonium chlorides, diazonium salt compound that contains cation and anion is said to be salt. So it is a diazonium salt, generally named as salt because the cation, this part is cation and this is an anion, diazonium salt. Now the name of this one is benzene diazonium chloride. Benzene diazonium chloride. When the benzene diazonium chloride is subject to the hydrolysis in the presence of acid, it gives phenol. So phenol is prepared by the hydrolysis of benzene diazonium chloride. Statement can be written like this: phenol can be prepared by the hydrolysis of benzene diazonium chloride. Phenol can be prepared by the hydrolysis of benzene diazonium chloride. Diazo అంటే 2 nitrogens. Nitrogen valence చూడండి 1 2 3 4 అందుకని ఇక్కడ ప్లస్. Cation, anion, salt from benzene diazonium chloride. This is one of the method of preparation. And other method from cumene hydroperoxide. From cumene. What is cumene? Cumene means this is isopropyl. Propane, when one hydrogen removed from the second carbon, that's said to be isopropyl. This is benzene. Isopropyl benzene is said to be cumene. What is cumene means? Isopropyl benzene. Commercial name cumene. Hydroperoxide. You know hydrogen peroxide. Hydrogen peroxide. Peroxy. The single bond between oxygen and oxygen said to be peroxy bond. Peroxy. Hydroperoxide. Now, cumene hydroperoxide. Let us take how to prepare. We have to take cumene, CH3. When it is exposed to air, the oxygen atoms inserted between the carbon hydrogen, see that cumene hydroperoxide. So when the cumene is exposed to air, This oxygen atoms comes between the carbon hydrogen and forms cumene hydroperoxide. This is the main reactant for the production of phenol. So how to prepare phenol from cumene hydroperoxide is up to this part only. You have to take, and how it is formed means this is the method. The cumene, it is cumene or isopropyl benzene. So it's in a hydrogen peroxide. If it is not there, if it is there hydrogen, you will write hydrogen peroxide. So in the place of one of the hydrogen, we have a cumene. That's why it's a cumene hydroperoxide. Cumene hydroperoxide on a hydrolysis gives phenol. Statement: phenol can be prepared by the hydrolysis of cumene hydroperoxide. Cumene hydroperoxide on hydrolysis gives phenol along with the acetone. Acetone is also very important product. Here it is a byproduct, it is a main product. Acetone, phenol, acetone. So this is a commercial method of preparation of phenol. So phenols, హైడ్రాక్సీబెంజిన్ ను ఫీనాల్ అంటారు. చూడండి, ఇది హైడ్రాక్సీ అంటే ఇది బెంజిన్, హైడ్రాక్సీబెంజిన్ నే ఫీనాల్ అంటారు. దాన్ని తయారు చేసే పద్ధతి క్లోరోబెంజిన్ నుంచి తయారు చేయొచ్చు. ఎట్లా అంటే క్లోరోబెంజిన్ ను అధిక పీడనము, అధిక ఉష్ణోగ్రతల వద్ద సోడియం హైడ్రాక్సైడ్తో చర్య చేసినట్లయితే ఫీనాలు ఏర్పడుతుంది. అధిక ఉష్ణోగ్రత పీడనాల వద్ద, పీడనం 300 అట్మాస్ఫియర్లు ఉండాలి. అధిక పీడనం, ఉష్ణోగ్రత 673 కెల్విన్లు అంటే 400 డిగ్రీల ఉష్ణోగ్రత సోడియం హైడ్రాక్సైడ్తో చర్య జరిపి ఏంది క్లోరోబెంజిన్ సోడియం హైడ్రాక్సైడ్తో అధిక ఉష్ణోగ్రత పీడనాల వద్ద చర్య జరిపి ఫీనాల్ను ఏర్పరచును. ఇక రెండవది బెంజిన్ డయాజోనియం క్లోరైడ్ను జల విశ్లేషణ చేయగా ఫీనాలు ఏర్పడుతుంది. ఇది బెంజిన్ డయాజోనియం క్లోరైడ్, ఇది ఒక లవణం. లవణము అంటే యానయాను కెటయాను కలిసి ఉన్న దానినే లవణము అంటాం. లవణం అంటే మనందరూ తెలుసు, ఇది సోడియం క్లోరైడ్, దీన్నే లవణం అంటాం. ఎందుకంటున్నాం, దానిలో ఒక కెటయాన్ ఉంది, ఒక యానయాన్. యానయాను కెటయాను ఏ దాన్నైనా సరే లవణం అంటాం. కాబట్టి దీన్ని ఇప్పుడు ఏమంటున్నాం మనం, లవణం. ఇదేమో కెటయాన్ డయాజోనియం, ఇది క్లోరైడ్, బెంజిన్ డయాజోనియం క్లోరైడ్. బెంజిన్ డయాజోనియం క్లోరైడ్ జల విశ్లేషణ చేయగా ఫీనాలు ఏర్పడను. బెంజిన్ డయాజోనియం క్లోరైడ్ను జల విశ్లేషణ చేయగా ఫీనాలు ఏర్పడను. తర్వాత మూడవది క్యుమీన్ హైడ్రోపెరాక్సైడ్. క్యుమీన్ హైడ్రోపెరాక్సైడ్ ఉంది. క్యుమీన్ హైడ్రోపెరాక్సైడ్ నుంచి ఎలా తయారు చేస్తారు? క్యుమీన్ హైడ్రోపెరాక్సైడ్ ఇది. ఈ క్యుమీన్ హైడ్రోపెరాక్సైడ్ ఎలా వస్తుందంటే, చూడండి, క్యుమీన్ అంటే దీన్ని ఐసోప్రోపైల్ అంటాం. ఈ భాగాన్ని ఐసోప్రోపైల్ బెంజిన్నే క్యుమీన్ అంటారు. ఐసోప్రోపైల్ బెంజిన్ను క్యుమీన్ అంటాం. ఈ క్యుమీన్ను ఇది అదే క్యుమీన్, దీన్ని ఐసోప్రోపైల్ బెంజిన్ అంటారు. ఈ ఐసోప్రోపైల్ బెంజిన్ను లేదా క్యుమీన్ను గాలిలో ఉంచినట్లయితే ఈ ఆక్సిజన్, గాలిలోని ఆక్సిజన్ పరమాణువులు ఈ కార్బన్కు హైడ్రోజన్ మధ్యన చేరుకొని ఈ కార్బన్, ఇది హైడ్రోజన్, ఒక రకమైన హైడ్రోజన్ పెరాక్సైడ్. ఒక హైడ్రోజన్ బదులు క్యుమీన్ ఉంది. క్యుమీన్ హైడ్రోపెరాక్సైడ్ను జల విశ్లేషణ చేయగా ఫీనాలు మరియు ఎసిటోను ఏర్పడను. ఎసిటోను, ఫీనాలు ఎసిటోను ఏర్పడను. క్యుమీన్ హైడ్రోపెరాక్సైడ్ను జల విశ్లేషణ చేయగా ఫీనాల్ మరియు ఎసిటోను ఏర్పడను. స్టేట్మెంట్ అది, ప్రిపరేషన్ ఇది. సో క్యుమీన్ హైడ్రోపెరాక్సైడ్ను జల విశ్లేషణ చేయగా మనకు ఎసిటోను మరియు ఫీనాల్. So methods of preparation of phenols over mainly chemical properties. We have to discuss about the chemical properties of phenols. The important chemical properties of phenols: Kolber's reaction. Kolber's reaction. What is Kolber's reaction? The reaction of phenol with carbon dioxide in the presence of base to form salicylic acid is said to be Kolber's reaction. The reaction of phenol with carbon dioxide in the presence of base to form salicylic acid is said to be Kolber's reaction. Statement can be written like this: the reaction of phenol with carbon dioxide in the presence of base to form salicylic acid is said to be Kolber's reaction. That is a statement. This is an equation. The another very important reaction is under the phenols, RTR. So what is RTR? Remier tiemann reaction. So remier tiemann reaction is the most important things under the phenols. Remier tiemann reaction. So what is the remier tiemann reaction is? See that the reaction of phenol with chloroform in the presence of base to form salicylaldehyde is said to be remier tiemann reaction. The reaction of phenol with a chloroform in the presence of base. The base may be sodium hydroxide or potassium hydroxide. In the presence of base to form salicylaldehyde is said to be remier tiemann reaction. The same statement was given. The reaction of phenol with chloroform in the presence of base to form salicylaldehyde or orthohydroxybenzaldehyde. See that it is the main functional group, it is a secondary functional group. So it is taken as substituent, it is taken as a functional group. Orthohydroxybenzaldehyde, it is commercially known as salicylaldehyde. So this is the remier tiemann reaction. These two are the important reactions on the phenols. Okay. So after the phenols, the next topic, ethers. Alcohols, phenols, ethers comes under the topic 12 in Telugu Academy book. So the next topic, ethers. What are ethers? Alkoxyalkanes. Alkoxyalkanes. Alkoxyalkanes are said to be ethers. So come to the naming of ethers. The first one, formula according to IUPAC system and common name. So you might have practice in your first year. Now let us take some of the examples in naming of ethers. The first one, see that this part is methoxy. Methoxy. Is there a methane? Methoxy, methane. This part, it is a methoxy. It is a methane. In the place of one of the hydrogen, we substituted methoxy. Methoxy, methane. Methoxy, methane. Common name, dimethyl ether. Second one, ethoxy, ethane. This part is ethoxy. Number of carbons 2. Ethoxy, ethane. Ethoxy, ethane. Common name, diethyl ether. Instead of that, if you take aromatic compounds, this part is methoxy. It is in a benzene. This part is methoxy. It is in a benzene. Methoxy benzene. Methoxy benzene. Commercially known as anisole. Anisole. Anisole is an alcohol or aldehyde or ketone or carboxylic acid. Sometimes they are asked like this: what is an anisole? Is it alkyl halide? Is it carboxylic acid? It is. Is it alcohol? Is it an ether? They will give 4 options. Anisole is alcohol, aldehyde, ketone, ether. So those who knows the name, they can answer. So methoxy, methane, methoxy benzene is said to be anisole. It can also be written like this. Methoxy benzene. So this is about the naming of ethers. Many names are there. You can practice from the textbook and come to the preparation. Many methods are there. Among them, the very important method, commercially large quantity of ethers are prepared from Williamson synthesis. Williamson synthesis is a very simple example I have taken. What is Williamson synthesis? Williamson synthesis is used for the manufacture of ether. Commercially, large quantity of ethers are prepared from the Williamson synthesis. Now, what is Williamson synthesis? The reaction of alkyl halides. The reaction of alkyl halides with sodium alkoxide. With the sodium alkoxide to form ethers is said to be Williamson synthesis. So, the reaction of alkyl halides with sodium alkoxide to form ethers is said to be Williamson synthesis. This is an example. See that sodium methoxide. This is sodium. This is methoxide. In the place of sodium, there is a hydrogen. It will be methyl alcohol. In the place of hydrogen, we substitute sodium. Sodium methoxide. Sodium alkoxide. It comes under the group of sodium alkoxide. It is in a methyl chloride. Methyl chloride. For convenient, I have written chlorine this side. Methyl chloride. Methyl chloride. This part is eliminated. As in a sodium chloride and methoxymethane. It is a kind of SN2 reaction. It is an example for SN2 reaction. This is a nucleophile. It is in a methyl chloride, primary alkyl halide. Primary alkyl halides reactions are nothing but SN2 reactions. So that's why SN2 reaction. You want to prepare diethyl ether, you have to take sodium alkoxide, sodium ethoxide, ethyl chloride. Depending on alkyl names, you have to take the sodium alkoxide, alkyl halide. You want to prepare diethyl ether, then here what we have to take? Sodium ethoxide. Here ethyl chloride, not methyl chloride. If you take methyl chloride, you will get this one. So the reaction of sodium ethoxide with the ethyl chloride to form diethyl ether. Like this, we can take number of examples for Williamson synthesis. So this is about the Williamson synthesis.